कहाँ inside outside which one? E at E. Like for A, I know that electric field is zero. For, for B, you have to calculate, and for B, you have to understand. Yeah. Yes. So you try to do it with the help of integration. Okay. Okay. Let me do. Let me do. See, for like the concept is simple. I have to always consider a Gaussian surface. Okay. So let's suppose if I consider a Gaussian surface at point A. So there is no charge inside it, isn't it? So first case for point A, flux is equal to integral E dot dA, which is charge enclosed by epsilon naught. Charge enclosed in that Gaussian region is zero. So therefore flux is zero, and that implies electric field is also how much? Zero. Is that clear? Second case, when I consider a Gaussian surface at region B, that's an interesting thing to understand, isn't it? 1 minute. So when I consider the Gaussian surface at point B, you can see that, I mean, let me align it. Yeah. You can see that the region enclosed over here is this much region only. This much region is inside the Gaussian surface, isn't it? So you see there are 2 points. One thing, till here to here means till center to inner radius there is no charge. But from inner radius to point B I have a charge, isn't it? So I need to find now that how much charge is inside. Look, yeah. So see that 4 point B. Plug means charge Q inside from center to R1 radius. Word or not? To capital R1. The charge is zero, isn't it? And I have to calculate the charge from inner radius till point B. So how to find it? Simple. I need to first find charge or not. So what will be the charge? Can you tell me? Simple. I'll since okay here a sphere is here for this reason a sphere is which kind of geometry? 3D geometry. So I need to use rho. So rho is equal to Q enclosed. Sorry. Rho is equal to Q by volume, isn't it? So ध्यान से देखो, अच्छे से देखो, काफी इंटरेस्टिंग पॉइंट है. Rho is equal to Q by volume, but this volume is of 4 by 3 pi. Only 3D volume exists between R1 to R2 or not. So R2 cube minus R1 cube. Is that clear? And this must be equal to charge enclosed till B. Okay. Divided by. So इसका volume क्या होगा? इसका volume simple 4 by 3 pi R cube, small r cube minus R1 cube. Are you able to get me? Why I'm subtracting R1 cube? Because in that region there is no charge. Is that clear or not? Is that clear? One minute. Try to do now. Is that clear? So this will get cancelled and charge till B I got, which is divided by R2 cube minus R1 cube. So simple, now I'll directly use my electric field calculation. So integral A dot dA for B is equal to charge enclosed I have got QB divided by epsilon naught. Is that clear or not? So this implies E integral dA. What will be integral dA? What is the surface area of a sphere? I need to find the surface area of a sphere or not? So it is simple 4 pi B square till over here. If I consider the Gaussian surface till over here, so its surface area will be 4 pi B square, isn't it? So that must be equal to charge enclosed, which is Q, capital R cube. Achha, capital R, this small r cube is basically what? This is located at B or not? So it will change to B, B cube minus R1 cube divided by R2 cube minus R1 cube. Is that clear? So in simple reasons, for point B, this implies electric field at point B is simply Q by 4 pi. This is epsilon naught times, sorry. So this is 4 pi epsilon naught B square and B cube minus R1 cube divided by R2 cube minus R1 cube. That's your electric field at point B. This is a very big equation over here, isn't it? Now, second last calculation, electric field at point C, isn't it? 4 point. No, for if I consider like let's suppose if I just consider point C, then no need of, it's an exterior point of all the charges or not, isn't it? So simple, no need to even consider the Gaussian surface. It's totally an exterior point, so, and this is an symmetrical body, so it will behave like a point charge kept at the center, isn't it? So electric field at point C is simply 1 by 4 pi epsilon naught. Total charge is given Q, and the distance of point C from the center is C, so Q by C square. That's your answer. That's your answer. Is that clear? So no need to consider these kind of things. Whenever you get these simple terms, you just utilize them. Hmm. Okay. Is that perfectly clear? Oh, cool. I'll give you a next question. Okay. There are many questions, many list of questions. Okay. Now, yes, let us do one particular kind of question. बोल रहा है कि I have a hollow cell, hollow cylindrical cell, a solid sphere, solid cylinder, a solid sphere. Okay. So look over here. See the question what it is saying. A solid sphere have variable volume charge density. Of course, it is non-conducting. Okay. Volume charge density rho is equal to, write it in, rho is equal to rho naught r to the power n. Okay. The question is very simple. Where r is the distance from center, question is find first total charge, second total charge on a sphere basically, E and V for r greater than r, and third E and V for r less than r. Is that clear or not? ठीक है? Do this question. So radius of the solid sphere is capital R. Try to do. बताओ क्या होगा? Okay, one hint how to handle this kind of questions. ठीक है? See, first identify what is given to you. Solid sphere. Solid sphere means 3D, 2D or 1D object. It's a ठीक है? So it's a 3D object, isn't it? Now, if I am considering it as a 3D object, then simple task is there. I need, and it is a continuous body, isn't it? And also density is varying. So it's not possible to solve in easy way. To solve it, you need to consider one kind of a element. What you need to consider? हाँ, मानना ही पड़ेगा वो तुम्हें. Without considering it, you can't solve it. ठीक है? So let's suppose I need to consider one element which has some thickness. Right or not? Is that clear? So I'll just consider that this is my element inside the solid sphere, because we can consider that a solid sphere is also made up of infinite number of disks, isn't it? Or yeah, basically infinite number of disks with varying radiuses. If I kept inclined on each other or planed on each other, they will keep a solid. They will make a solid sphere or not. So I'll consider a disk of some small radius r. Take, and thickness how much? dr. dr. Is that clear? Where the total radius of the ring is capital R. Is that clear? Now, or if you make this as a disk, basically people, all the people, they consider in some different way. They consider that uh, a solid sphere is made up of infinite cell. Check. We have infinite cell elements of radius a small r and thickness dr. Means we consider that they are made up of, instead of considering even disk, we will consider that they are made up of infinite number of hollow spheres which has some thickness dr. Are you able to get me or not? That is also a correct idea to measure it. मान सकते हैं ना कि एक सॉलिड स्फीयर उसके अंदर ऐसे ऐसे सेल है हजारों, उन सबको जोड़ दिया तो क्या बन जाएगा? सॉलिड स्फीयर बनेगा, है कि नहीं? So look over here, the volume of any solid, any such cell will be given as what? 4 by 3 pi r cube. But this volume is very small, isn't it? So I need to measure dV, and this volume is varying with respect to radius, so I need to calculate dV by dr, isn't it? So that will be equal to how much? 4 pi r square, isn't it? Because 3 r square, it will come 3 got cancelled. So this implies volume is dV is equal to 4 pi r square dr. Are you able to get me or not? Now, if I know my chota volume of this, means I know the dV of this, got it or not? So then I can write in terms of rho. Rho is what? Small charge in that cell by a small volume. Like it. So then dq will be how much? Rho dV. So rho into 4 pi r square into dr. Is that clear or not? Is that clear? Now here rho is varying in terms of rho is equal to rho naught r to the power of n. So this will be given as what? Rho naught 4 pi r n plus 2 dr or not. That's my variation. कुछ तो बोलो हाँ या ना. So first question का answer total charge I have to calculate. So total charge is simple. If I can see, this is my value of dq or not. So dq is given as rho naught 4 pi r to the power of n plus 2 dr. So if I just integrate it, I'll get the total charge, and I should integrate from 0 to capital R, isn't it? So total charge capital Q is simply how much? Rho 4 pi rho naught or rho naught into 4 pi capital R. This will become R n plus 2 plus 1 divided by n plus 2 plus 1, isn't it? And 0 to capital R. So this becomes how much? Rho naught into 4 pi r to the power of n plus 3, means capital R to the power of n plus 3 divided by n plus 3. That's my total charge. Is that clear? Now I am required to find electric field and potential for R greater than R and R less than R. So R greater than R, it's very easy, no problem. Simple. Put the total charge, because this for external point it will behave like a point charge, isn't it? But for inside it, I'll have to calculate, isn't it? So inside it, if I, let's suppose if I want to know the electric field at this point only, at a small r. So once again, According to Gauss law, if I create a Gaussian surface over here, so third question I'm doing directly at inside point. Take. So if I consider, I need to apply flux. Flux is equal to integral E dot dA, which is equal to Q enclosed by epsilon naught, isn't it? So if I want to write E dot dA, so it will be E dA क्या होगा 4 pi. Surface area of this Gaussian surface is 4 pi r square, isn't it? And charge enclosed in this is simple. I'll not integrate till 0 to r. I'll just integrate till a small r, isn't it? So till a small r, this will be what? Rho naught into 4 pi r to the power of n plus 3 divided by n plus 3 into epsilon naught. Is that clear? Are you able to get me? So now 4 pi got cancelled and it will be subtracted by 2 times. So E inside is simply rho naught r to the power of n plus 1 divided by epsilon naught n plus 3. That's your answer of electric field inside. Is that clear? Are you able to get me? So that's how you need to do. That's how you need to understand. Is that clear or not? Similarly, I want to find potential over here. So look over here. Once again, same thing. To find, I know the electric field inside, isn't it? So potential at inside point will be integral minus of integral E dot dr. है कि नहीं है ना? So that is equal to how much? Integral 0 to infinity to capital R पहला E dot dr minus R to a small r E dot dr, isn't it? ठीक. So look over here. Exteriorly, the electric field will behave like a point charge, isn't it? So I will write the E outside equation. E outside will be how much? Simple, Q by 4 pi epsilon naught R square. What is Q? Rho naught 4 pi R to the power of n plus 3 divided by 4 pi epsilon naught small r square n plus 3 or not. That's my electric field outside, isn't it? So you just put it over here. Are you able to get me? Now if you put it over here, that is simply just kq by r, isn't it? So we can put it, we can just get the electric field. It is 4 pi cancel, so rho naught by epsilon naught r to the power of n plus 3 divided by n plus 3 integral, this is minus, okay, infinity to capital R 1 by r square dr minus इसका integration, this is rho naught by epsilon naught n plus 3 outside integral r to the power of n plus 1 dr from r to small r, and that's your task to solve this integration. Are you able to get me? That's not my task. Okay, is that clear or not? So you got to know how to find the potential and how to, and similarly if I want to write the potential for outside point, it is what? Kq by r, isn't it? So 1 by 4 pi epsilon naught. Q is rho naught 4 pi r to the power of n plus 3 divided by kq by r. So n plus 3 into divided by small r. So that's my outside electric field potential, and this is my outside electric field. Are you able to get me or not? Is that clear? So that's a nice thing we did today, isn't it? So many great kind of questions. So just there is a trick. The trick is simple. If it is Normal solid sphere, non-conducting, of density rho and radius r, then electric field inside is, outside is very very simple. It's rho r by 3 epsilon naught, isn't it? Rho is small r by 3 epsilon naught. Just rho is given, isn't it? Solid, if it is solid cylinder, non-conducting, because for conducting it's very simple. Rho and r, it is electric field inside is rho r by 2 epsilon naught. Is that clear or not? Now, if in some case, if for these cases rho starts to vary as rho naught r to the power of n, is that clear? So n can be 0, 1, 2, 3, any number. Is that clear or not? Then the electric field for both of them will start varying. E of solid cylinder, E inside of solid cylinder, solid sphere first, will be given as rho naught r to the power of n plus 1 divided by not n plus 1, n plus 3 into epsilon. Is that clear? And here we are getting due to this term r square term. Is that clear or not? So similarly, here also E outside, E inside of solid cylinder, it is given as what? So for solid cylinder also it will vary as 2 pi r dr, isn't it? Look over there. For solid cylinder it used to vary as 2 pi r in terms of pi r square. Are you able to get me or not? Because it is dA over there, not dV. Here it was dV, so it was r square dr. So this one will come as rho naught r to the power of n plus 1 divided by n plus 2 into epsilon naught. Is that clear? You can see for example, see for normal case, rho, for rho and rho, n value is how much? 0. And here n value is how much? 0. So put n value as 0, you will get what? Rho naught r by 3 epsilon naught for solid sphere, and for solid cylinder it is rho naught r by 2 epsilon. Are you able to get me? So ma'am, is that clear? Okay, so I'll give you one question based on this. You try it, and that will be your homework. Okay. बोल रहा है, if rho is equal to alpha by 7 r square, then uh, okay, then find uh, yeah, then find electric field inside for solid non-conducting sphere. Take second question. If electric field inside is given as 8r cube, then find rho of a sphere. Take. Are you able to get me? So you have to do this by yourself and check whether what is your correct answer or not. Okay. And then we'll meet tomorrow. Not tomorrow, day after tomorrow at the same time. Is that clear?